Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. A square and a rectangle with two unequal sides have equal areas. We are given two quantities to compare. Quantity A is the perimeter of the square and quantity B is perimeter of the rectangle. And this is a very common format of quantitative comparison problems that are asked in GRE. So let's consider a square and let the length of each side of the square be A. So it's got all its sides equal and the area of the square is A square. Next, consider a rectangle. And this rectangle has two sides, two unequal sides, and let's call those sides x and y, and x and y are different from each other, so they're not equal. Otherwise, the rectangle would be a square, right? And the area of this rectangle is simply the product of the two sides, x, y. And the constraint that we're given in the problem is these two areas are equal. So it's a square equal to xy. So this is the defining relationship from the problem. Now, one approach, and this I have seen in multiple places where they have discussed approaches to solving, quantitative comparison problems, is, testing some values of the quantities and seeing how the relationship holds up for those values, and accordingly come at a conclusion. And I'll show you this example. For this particular case, we can let a equal to 6. I'm just picking an integer. Then the perimeter of the square will be 4 times the length of the side. So it's 4a. And since a is picked as 6, 4a is 24. What about the perimeter of the rectangle? Before finding that, we need to consider the relationship that the product of the sides xy is equal to a square is equal to 36. And from this, we can pick values of x and y such that their product equals 36. I'll go again with very simple integer values for x and y. Let's pick x equal to 9 and y equal to 4. And the perimeter of the rectangle will be 2 times x plus y. And in this particular set of values for x and y that I have taken, x plus y is 13, 9 plus 4, 13. So 2 times x plus y becomes 26. So we can see that for this set of values of x, y, and a, the sides of the rectangle and the side of the square, and we have taken those values in such a way that they conform to the constraint that a square equal to xy. And we see that the perimeter of the rectangle for these set of values exceed the perimeter of the square. And we can, pretty much test other values, other set of values of a, x, and y. Now, this is one approach. And in this particular problem, it does lead us to the right relationship or the right answer. But this approach of testing the relationship for a set of values doesn't really help us get to the correct answer always, because it does not help us rule out option D. Just because a relationship holds up for a certain set of values doesn't necessarily guarantee that the same relationship holds for all possible set of values. So how do we obtain a more generic solution that will help us arrive with greater confidence that indeed the perimeter of the rectangle is going to be greater than the perimeter of the square, no matter what values of a, x, and y may be, as long as their areas are equal, that is a square is equal to xy. And for this particular problem, it's actually an even simpler one-line solution than testing with values, if you know what to do. So the relationship I will take advantage of here is an inequality which is kind of well known. And that inequality basically states that for two unequal positive quantities, the arithmetic mean should be greater than geometric mean. And I have quoted here 2, but this is a relationship that's pretty much true for n number of unequal positive quantities. Now, if the quantities are equal, if we remove the constraint that they have to be unequal, then this greater than sign is basically replaced by greater than equal to. But if I specify that there are two unequal quantities, then I can basically write a strictly greater than sign. So arithmetic mean a greater than geometric mean for two unequal positive quantities. And if those positive quantities are the sides of the rectangle x and y, and which are given to be different, what is the arithmetic mean of x and y? It's simply x plus y divided by 2. And what's the geometric mean? The geometric mean is simply root xy. Now, if you remember, by the problem, xy was basically equal to a square, right? So on the right hand side of the inequality, we can substitute xy by a square. But before we do that, we basically multiply both sides of the inequality by 4 just to get the perimeter of the rectangle on one side. So this is just simple multiplication. We multiply both sides by 4, and our left hand side of the inequality becomes 2 times multiplied by x plus y, and the right hand side becomes 4 root xy. And now we take advantage of the relationship a square equal to xy. So in that square root xy, you simply substitute a square. We have 2 times x plus y greater than 4 multiplied by root over a square, which simply comes to this inequality, 2 times x plus y greater than 4a. And if you notice the left hand side, like I said, we have already made it so that it equals the perimeter of the rectangle. But the right hand side, 4a, is the perimeter of the square. So what this says is the perimeter of the rectangle is greater than perimeter of the square. And this is pretty much true for all possible sets of values of x and y, as long as they are different. And that's given as a problem, that we have two unequal sides, right? So this is a more generic way of coming to the conclusion that the perimeter of the rectangle is greater than the perimeter of the square. So the correct choice in this case will be option B.